Right. For today, guys, we continue our discussion of the absolute value function, like we did previously. But at the moment, we want to look at inequalities. And I'll just write the inequalities, but we must know that we're discussing inequalities involving absolute value function. All together. Okay. Now, talking about that, I think the first thing to look at is to look at the absolute value of A. I'm sorry, I want to say absolute value of X less or equals to A. I would like to put something also in brackets here and say we also got to have in mind the absolute value of X less than A. The difference is just the inequality, strict inequality or that. That's what. Now, let's have a number line here. I think the best thing to use a number line. I hope yesterday you get the message correctly that the absolute value, we can talk of the absolute value as a distance from the origin, isn't it? Distance measured in the number of units, like 1 is being a unit. That's right. Okay. So now let's say you've got a 0 here. What's happening to me? Let's say we've got a 0 there, and we've got A there, and minus A somewhere there. Then let me ask a simple question. If I've got a number here, this region, you can see that, no? You can see where I'm pointing there. Can you say that number, the absolute value of that number is less than A, or is more than A? The absolute value of the number here is less than A. What about the absolute value of the number there? It's what? No, I don't get it. I'm saying we're talking about the absolute value, remember? I'm saying if I pick a number, you are saying to me, if I pick a number here, that absolute value of that number is less than A, isn't it? Now, if I pick a number there, the absolute value of a number here, is it less than A? I'm not saying the number is less than A. I'm saying, is the absolute value less than A?
No.
No. Is it? How is it? It's bigger than A. It's bigger than A. It's bigger than the absolute value of A. Okay, good. So what about here? Less. Altogether. So now I think you can see now, when we are talking about number, this inequality, we're actually talking about numbers which are lying somewhere there. And that is an interval, isn't it? That is an interval. So how can we express that interval? We can say, once we write the absolute value of X less or equal to A, this is equivalent to saying X is between minus A and A. Is that clear? Are you understanding that? Sorry? So now, if I were to represent that thing in a picture form, this is what I would do. Check. I'll come to A here, and then draw a line there, and then draw a line there above that. Then put a dot there. What am I trying to do there? I'm trying to say minus A is included. What tells me minus A is included? The inequality. Less or equal. Here, do the same thing and say A is included. So I'm talking about all the numbers from minus A to A. And that expressed analytically, I express it this way. Altogether. So that the interval, that picture interval, that picture of the interval is representing this mathematical expression. Altogether. Okay. Good. So if it was not like I was using strict inequality, like I said the other day when we was on piecewise graphs, I can still do this above the line, but I'm just putting it above the below the line because I'm going to be crowded, isn't it? So I can then put open circles there, direct below there, direct below there. then I say I'm talking about the number which are strictly in between the two numbers. Am I making sense? Sorry? Does that make sense? My friend there? Okay. Okay. So I hope you understand that. That's right. So this you're going to be using to solve inequalities involving absolute value. Now let's look at another inequality. Let's say with absolute value of x greater than a. Now I'm not going to use greater or equal. I now understand that if it's equal, you know what to do. In terms of the picture, if it's not equal, you know what to do, isn't it? Now for this one, there is the number line. I'm starting with a clean number line here. Our 0, the reference point is 0. Our A is there. Our A is there. Right. So now we are talking about absolute value of the numbers, absolute value of x being greater than a. Who can tell me in your own words where do you think those numbers are? Or you can give me a sign where you think the numbers are. So outside the previous interval. They don't include a, they don't include minus a, but outside the interval. So they what we're talking about. We're talking about not a included all the way that way. Isn't it? Yeah. And then here, minus a not included all the way this way. Sorry for that. Okay, it's my first time to work on this thing standing like this. It's so difficult to handle. Yeah, this venue is cruel for me. So are we understanding, guys? Okay. So that's that. So now maybe let's look at examples which you can solve. In this case, when you're solving this equation, I think you can see the solution to these types of inequalities is not going to be a single number. It's going to be like a set of numbers, or an interval, or two pieces of interval. Is it? Okay. So like this one there, writing this. Where is it? This one. When I've got absolute value of x greater than a, you just mean that x is less than minus a, which we've been talking about this side, isn't it? Or x is greater than a. So you must be able to translate this thing to this from there, take it to there, take this one, the previous from there, take it to this kind of thing, isn't it? Yeah, and be able to translate into a geometric, like a geometric picture, and see how we can do it graphically. Am I making myself clear? Okay, let me take an example. Okay, let's say we've got, oh sorry, let me just clean this first. Examples. In this case, examples on solving inequalities involving absolute value. Now let's have got here absolute value of 2x minus 1 is less or equal to 2. What we need to do here, you need to be able to solve this equation and at the same time be able to represent the solution graphically. So from the first inequality we said this means that minus this expression A is between minus 2 and the 2 altogether. So you should notice that when I unwrap it like that or expand it in this way, the absolute value, the notation, those bars are no longer there, isn't it? They're no longer there. So now, from there now, we solve this as an equation. So now, an inequality like this one has got 3. I don't know what you can say 3 sides, but we have got 3 terms that involved. One between the left right center and the left hand side. But what we want to do, we want to remain with a condition which talks about x in the middle here. We also want to put a condition on x. So we must make sure that we leave x here as an independent term, which has no coefficient like 2, which has nothing added to it. We just talk about x. Am I making sense? So the first thing is, you basically temporarily look at this thing as an equation. Like if I'm looking at solving an equation 2x minus 1 equals to 2. Or I'm looking at the equation 2x minus 1 equals to minus 2. Altogether. So, but we'll do this simultaneously. What do you think we should do? The next thing would be 2. Before we can worry about this 2, we need to worry about this 1. Isn't it? We must find a way of sorting that 1 is not there. But the only thing to do is to create a 0 there. How do I create a 0? I will say minus 2 plus 1 less or equal to 2x minus 1 plus 1 equals to 2 plus 1. What am I doing there? I'm doing exactly the same thing on all the terms of the inequality, isn't it? I'm not moving anything. What am I taking advantage of? I'm taking advantage of the property of numbers which says a plus minus a is the same thing as a minus a equals to 0, isn't it? Why I want to get a 0 here so that I can only be left with a term which contains x. So this is 0 plus 2x. Then I've got 2x less or equals to 3 greater or equals to minus 1. Altogether. Then, after that, we've got this 2 here. We don't need that 2 there. We just need to ask ourselves our question. What is that 2 doing there? It's multiplying, isn't it? Then we call for an inverse operation. Remember, when we talked about inverse thing, I said the inverse is the one which makes it possible to solve the equation, isn't it? So it also works in inequality. So now, inverse of multiplying is what? Is division, isn't it? So I'll divide by 2. But when I'm saying divide by 2, I mean exactly the same thing as multiplying by half. So dividing by 2, I'll get this thing as minus 1 over 2. And the 2 over 2 is equal to? What is 2 over 2? 1, then I've got x, then I've got that, that's 3 over 2. Then what do I do next? Is to maybe try to draw a picture of this. Okay. So when I try to draw a picture of this, I'll draw a line, straight line. I think to orient myself, I will always need to put a 0. Then minus half, let's put our 1 here. I'm just using a big scale so that I can make it more visible, isn't it? So then put our 1 there. Actually, this is our minus 1, isn't it? So if minus half, we get somewhere there. And the other side, 3 over 2. What is that? It's 1 and a half, isn't it? So then 3 over 2, somewhere there. And then this is said in between. Apart from using what we did before, what we can now do, if I don't want to draw it somewhere above there, I can now just put a dot here and put a dot here which says those numbers are included. Then I just thicken the line here. I'll be using a ruler, isn't it? I'm just indicating when the numbers I'm talking about are lying. So those numbers there, that interval, is a solution set. Now, any value I pick there is going to satisfy that condition of that inequality. Am I making sense? Okay. All right. So that's one example. You can, I can't remember what's the page in your book, but if I'm not mistaken, it's about this page 88 in your book. You get this type of service. Please go there and do practice. This is what definitely I'm going to expect you to know how to do this and solve problems you're going to do. All right. Question? Question? Yes?
The coefficient is negative.
The orientation of the inequality sign changes if, like for example, if this minus 2 was, if this was minus 2 instead of 2x, and they want to have x not minus x, then the orientation of the inequality sign would change. Out well. Okay. Maybe I'll look at another example which involves that. All right, guys. Another question? No, please don't open the books now. You open the books at home. Huh? Okay. I'm talking about the textbook, but you can write your notes if you need to write your notes. If you need to write some short notes. Right. So let's come to troubles. Let's get another example and see whether I can handle this one. Let's have the absolute value of x minus 1 brackets greater than 2. Altogether. So please, I want you to attempt it. You attempt it first. But I remember, now we have got an O. Is that right? Yeah. So you have to use an O there. I'll pause there for a while and give you a chance to think about it and waste your time to push your pen against the paper. Right. Tell me, what's your first step to handle that? What did you write? Tell me what you wrote. Come again. X minus 1 greater than 2 or x minus 1 less than minus 2. Good. Altogether. Then I think what is left now is simple work, isn't it? So what did you get as your answer this side? You add both sides plus 1, isn't it? X is greater than 3 or x is less than minus 1. you can visualize the picture of that situation, isn't it? So let's draw it. Always put your 0 reference point. You can see you've got -1 plus 1. So you have to choose a scale. And where you can say that is -1, -2, you need 3. Then you can go 1, 2, 3. Then you can represent your. So maybe there you can just say open circle there, point in that direction. Out well. Then you come here, what is that? -1. You put an open circle there and say all the way in that direction. Then you've got your complete solution and there is geometric kind of a picture. Is that fine? So I hope that is making sense. But if it's not making sense, guys, you shout there, then we can see how we can help you. If anyone got a problem, anyone wants to ask or comment, you want to ask something? Yes? I don't know what to, because you know what is the inside the bars. You take it as it is. No, I'm not going to that. I think that's what is going to confuse you. Take it just like we teach it at the beginning, that when something is better, it means it's less than that limit, or it's more than that. That thing which is inside it, but as it is, it must be more than 2 or less than -2. That's the correct statement to say. No. I would really understand what one lecturer said, but let's see whether we can give a shared meaning, you and me, that when you've got that kind of situation, the first line to write is actually this one. It is basically according to that base, that first inequality is discussed. The less equal or the greater equal. Then when you go through that, maybe I don't know. Maybe if I see you writing it, maybe we can talk about it. Yeah, but for now, because we don't have a board here, I could just ask you to go and write on the board, then we can discuss it. But you can maybe later if you want to discuss it, then we can talk about it. That's right. Okay. Right. Any other further question there? Further comment? Yes, I'm looking for a study guide. I don't know whether I'm right. And the one thing which I noticed, this compilation of exercises doesn't have the problems on absolute value. But I've given you page 88 of your book is dealing with that. You've got a number of absolute values. That's why I got this jump I'm doing myself. Otherwise, if you have nothing further on the absolute value, maybe let's round up. First of all is the definition of the absolute value, so how we define it. And maybe I can mention also some few properties of absolute value, like before I just conclude. Like if you've got A times B, the absolute value of this is just simple the absolute value of A multiplied by absolute value of B. Like multiplication does not. What about the order? So it's like taking the absolute value of this number. Then also if you've got A over B, assuming B is not equal to 0, the absolute value of this is going to be the absolute value of A over the absolute value of what? Of B. Then I would write you, I think these are few which I can highlight here. And if you've got A plus B, the absolute value, this absolute value is always going to be less than the absolute value of A plus the absolute value of B. This is more or less to do with the principle, I don't know what to call the principle, or fact that if you've got 2 points, the shortest distance between 2 points is a straight line, isn't it? Yeah. So it's more or less something to do with that. Like let's say I've got A here, and I've got a point there, and I've got a point there. This distance plus that distance will always be greater than that distance. So this distance will always be less than this distance plus that distance. Altogether. So now it's saying the shortest distance between 2 points is going a straight line rather than going via another point. Altogether. Yeah, something like that. So otherwise, the rest of the properties, please, I invite you to go and look at your book and try to understand them. If there are questions, you can come back to me. Otherwise, I'm going to say at this moment, thank you for listening for this part, then we're going to carry over to something else which is not really absolute value. Is that all right? Okay, thank you.